Okay, I think we can start. Okay. Hello. Okay, so yesterday we have seen liability. What does it mean? What does it imply? And how we can solve problem sets and exercises related with the concept of strict liability and negligence. Today we're gonna review a similar topic, a related topic, which are voluntary programs. Okay, so first of all, what is the difference between a voluntary program and a mandatory program?
Well, voluntary you can choose to enter into the program, but mandatory it's given.
Okay, and who decides, who sets out the mandatory program? Regulator can ask for a mandatory program, of course. The legislator. Okay. Okay. Last question, and then I let you go. Which are the incentives for a firm to adapt a voluntary program instead of a mandatory?
Because if they go with the voluntary program, they might stop the mandatory program being also give like a higher regulation than they would have been for voluntary.
So the cost might be...
Cost will be more, maybe.
Okay. Other reasons? As a firm, why should I?
Again, competitive advantage over those who don't adopt the...
In terms of signaling or in terms of...
potentially signaling the market and in terms of innovation.
Okay.
Technology.
Yes. Yes. So you can set different standards for the competitors in terms of marketing and in terms of technologies, maybe. What else? What about the relationship between the regulator and the firm? So if I am a firm, why should I decide to enter in this kind of programs if we consider my relationship with the regulator?
So it's more constructive.
Yeah, more constructive. It's better to have a happy regulator than a pissed off regulator. Yeah? Okay, perfect. These are the main reasons why the firm might decide to adopt a voluntary program. What about the regulator? What is looking at?
Cost.
And?
What is the environment?
Okay.
And the benefits. What is it, the NBA?
VA? VA?
Yeah.
This is voluntary agreement. And MA should be a more mandatory agreement. Yeah. But then, of course, as you said, the regulator will look at maximizing the net social benefit. Yeah? So, the benefit from abatement minus the cost that some part of the society have to consider the firms. Okay? So you can see that from one side, the firm will try to minimize the cost. From the other side, the regulator wants to maximize the benefits. Yeah? In all of this, we have the legislator. The legislator sometimes decides to put a mandatory agreement. Yeah? Sometimes because it's not always the case, yeah, for different reasons, like frictions in the legislation process, maybe there is disagreement, maybe there are more important things to care about in that moment. It's not certain that the legislator will set up a mandatory agreement. Okay, so in all of this we have the uncertainty related with the legislator activity. Okay, now considering all of this, let's start to see the questions. Yeah. Okay. First of all, we have a voluntary agreement model with a legislator, a regulator, and a firm. It's not a joke. Okay, we have an abatement level A, and the regulator decides whether to offer a voluntary agreement. Okay? In this case, the firm has to decide to adopt the voluntary agreement or not. If the voluntary agreement fails to materialize, yeah, the legislator will adopt mandatory legislation with a probability P. This means that it's not certain. Yeah? Okay. The cost to the firm of abating are CV in case of the voluntary, CM in case of the mandatory. Okay? Of course, we assume that the costs related with the voluntary program are lower than the mandatory program. Yeah? Why is that? Because otherwise the very first incentive of the firm to accept the voluntary program wouldn't be there. Yeah?
Sorry, quick question. Is there a cost differential to the regulator that we take into account between mandatory and voluntary agreements?
A cost for the regulator?
Yeah.
No.
No. You assume that the cost is the same?
Yeah, for like implementing the mandatory. So
Yeah.
it's a cost related also with the legislator.
Okay, so the only cost variable is with the firm?
Yes, yes. So this is not included in our cost-benefit analysis, let's say. Okay? So, of course, the firm will wants to minimize these in terms of abatement, of course. The regulator will look at the net social benefit. Yeah? Benefit minus the cost. In case of voluntary, we put a V. Otherwise, we have N, mandatory. Okay? Okay. So, what is this B? This B is defined as 20A minus A squared. Yeah? The cost functions are these two, 5A and 6A. And we have everything we need. Okay? We have the cost, we have the benefits. Okay. First point, compute and graph marginal benefit and the two marginal costs. Okay. How can we compute these three? What should we do? Okay. So, what is the first derivative of this benefit function?
20 minus 2.
20 minus 2a. Perfect. What about the other two? 5 and 6. Yeah. Okay. So, perfect. Given that we have these three values, we can graph them. Okay. Let's see. Okay. In this case, you can see that we already have here the three derivatives. As we said, we have 20 minus a, 5 and 6. We can graph them. Here we put marginal benefit and marginal cost. Here we put abatement. Yeah. The two costs are straight lines, of course, because the marginal cost is equal to 6, marginal cost mandatory is equal to 6, marginal cost voluntary is equal to 5. And then we have the marginal benefit. Yeah. When a is 0, marginal benefit is 20, and then we go until 10. Yeah? Okay? Okay. So, first step. All clear. Good. Second.
You will be 10 in the next one? You will be
yes, marginal benefit. It's like, yes. So you put, okay. Because you put this A from the other side.
Yeah, so
it's 2A instead.
That's a
It's
mistake.
20.
It's 2A, yes,
Yeah.
yes. This is a type. Okay. Okay, so let's see. Now, we have seen, we have computed and graphed the three functions, right? Now, at this point, we should algebraically and graphically compute the net social benefits, yeah? Okay, how can we do that? Of course, we need two values. We need the value of abatement for the mandatory program and the value for the voluntary, yeah? 7 and 5. Okay, up to this point, we assume the probability of the legislator to impose the mandatory scheme as certain, so as equal to 1. Yeah? So we don't put any different probability except for 1. Okay, so it's certain. Okay, so taking into account the definition of net social benefit, yeah, we just need to plug the two values here and here, and then instead of A, in this case we are in voluntary program, so we plug 5. Yeah? For this case, instead we plug, instead of B, we plug this one here, because the benefit is always the same. Yeah? And then we put the other cost. Yes?
Just one general question. Why do we have different formulas for the cost of abatement? If I want to abate 5, it will be the same cost if it's mandatory or voluntary. Why is that?
Yes.
Why
So
5A and 6A?
because we want CV lower than CM by definition. Okay. So for this example, for this reason, we are just putting these two.
We are just assuming that the mandatory agreement will be more expensive than any voluntary thing we can do. It doesn't make really sense.
Well,
would the regulator force me to do something that is more expensive than other thing I could do to achieve the same level of movement? That's my question.
To get more results.
yeah. So to you try
To get the
to.
same result at a higher cost. Doesn't
Well,
make sense.
If the voluntary doesn't achieve the results, then
Yeah.
the
So
mandatory plays at a higher cost.
we'll see this later with the game tree, but basically the reasoning is we are trying to incentivize firms to get involuntary. Yeah. So it means that they need an incentive to get it. Yeah. So excluding the other examples, the other reasons that we might think, it needs to be economically convenient. Yeah. So at this point, we say, okay, we will try to get in, we will try to convince them. If they don't want, we will put the mandatory. Yeah. So first of all, if you don't decide to voluntarily participate, you will spend more. From the other side, it's not completely sure that you will. Yeah. So the more stringent regulation is the threat, the mandatory, which is also related to the fact that there is a chance that it will not be implemented. Yeah. Because of the frictions in the legislator activity. Yeah. Okay. Because otherwise it would be very, very convenient not to like participate in any voluntary agreement. Yeah. Because maybe no one will do anything in the future. Yeah. Not in point A and B, but then in reality, yes. How many times we say, okay, this problem should be taken by the legislator and some agreements should be implemented, but then it's not always easy, not in all, in particular countries, especially in particular countries. Okay.
Then why put the sentence do not take into account the probability or mandatory
So far,
yet?
yes. So now we are just trying to see how the things are going in general, for like just because the first points are simpler. Then we add the component of uncertainty.
Okay.
Yeah, and we try to give a value, an expected value to the probability. Yeah. Okay. Okay. Let's see which are the results of the net social benefit, and let's try to see it graphically. Yeah? Which is point B. Okay, so as we said, the method is plugging the 5 and the 7, yeah, into the two definitions of net social benefit. Okay, both for voluntary and mandatory agreements. Yeah. In this case, you can see already that the regulator has an incentive to apply the voluntary scheme, because the net social benefit deriving from the net from the voluntary scheme is higher. Yeah? So we have a higher net social benefit considering the cost that the firm needs to take. Yes?
Where have we got the 5 and 7?
They were just given by the exercise.
Oh.
We assume AM equals 7 and AB equals 5. Okay? Now that we have all the values, we can also try to draw these two net social benefits. Okay? So, first of all, let's try to draw to see where the net social benefit in case of a mandatory scheme is. Okay? So first of all, one second. Okay, I think that this is nicer for you. Okay, first of all, we have the mandatory scheme, yeah, equals to 6. In this case, of course, if we have a mandatory scheme and you have a marginal cost equals 6, well, the firm will abate up to the point in which the marginal benefit is equal to the marginal cost. Yeah. So, in this case, we have 7, which is the abatement that we have found before. Yeah. Okay. So, in this case, all the net social benefit is all the triangle minus what I spend, which is the area below the marginal cost. Okay, so all this rectangle is what the firm is spending, all this area is the total benefit, so the net benefit is this triangle here. Yeah? Okay. Then the exercise also gives us another value, the value for the voluntary scheme. Yeah? In that case, we know that the optimal abatement, the decided abatement, will be 5. Yeah? This is given by the exercise. So we know that the marginal cost in the voluntary scheme, the voluntary agreement, is 5. We know that abatement AV is 5. Okay, so all this orange area is the net social benefit in case of voluntary agreement. Okay, so how can we see whether the net social benefit is bigger in one case or in the other? Well, first of all, we can do as we have done before. We can think about this graphically too. Yeah. It will be convenient to adapt the voluntary or the mandatory according to the two areas. Yeah? So basically, you are comparing this rectangle here with this triangle here. Yeah? Who is the bigger dominates in terms of net social benefit. Okay. In this case, in the solutions, we are also computing the areas looking at the graph. Yeah. So in this case, of course, you can use the trapezium formula instead of a rectangle plus a triangle, but whatever. Okay. So first of all, we compute them mathematically, plugging in the values, and then we show the result graphically. Okay. Okay, now, for my students of the optional module, this exercise will be very, very easy, but I think also for the other students, because we have seen this in the seminars, and then we have seen this with Paul and Paul. In this case, we need to do a decision tree game. Yeah? Why? Well, we have different phases of our game and different players. Yeah? This is something that you also have in the slide, I think. Okay, so sorry, I will go here because there is the camera also, and for the ones that will see the video later on. we have the first step in which the regulator decides whether to offer or not a voluntary agreement. Yeah? How can he do that? Well, first of all, he needs to compare the net social benefits. Yeah? Is it convenient for us? Yeah, it seems so. So I will offer a voluntary agreement. Yeah? For example, in this case, the firm can decide whether to accept or reject the voluntary agreement. Okay? In the third step, we have the legislator. Yeah? Okay, so if the firm accepts the voluntary agreement, well, the legislator will not take any action. Yeah? If the voluntary agreement is rejected by the firm instead, the legislator will enact the legislation or not. Yeah? With a probability P. Okay? So, we have a probability P that the legislation will be enacted and a probability 1 minus P that there will be no action. Okay? Additional case. We have the regulator which decides not to offer the voluntary agreement, yeah? Which is a possibility. In this case, the firm can act, can decide whether to abate more or less, blah blah blah, but is not required to accept or reject any offer, right, from the regulator. The third step is very similar to this one. Yeah? The legislator might decide to enact a legislation. Yeah? So to regulate this sector with a mandatory agreement. Yes.
With
Yes and yes.
Voluntary agreement. You're basically saying that we agree on a level of emissions or a level of abatement, and the firm decides how to achieve that level.
Yes.
And the mandatory side would be something like, okay, we're enacting a law that all companies that produce, I don't know, CO2 should put like a filter outside or something like that.
Yes, we are in
the difference, because I'm still not clear.
in this set. We are in the agreement. We are referring to the abatement. That's why in point B we are giving a value for mandatory and a value for voluntary. Yeah. So no matter the technology, in this case we are saying, okay, we want an abatement level of 7 or an abatement level of 5 in the mandatory, for example, or the opposite. Okay. So the agreement is based on the level of abatement. Okay. This doesn't mean that there might be other kind of agreements, as you said, based on technologies or technology standards for all the sector, etc., etc. Okay, but in this case we focus on the quantity abated. Yes, and then yes.
So I didn't understand exactly the probabilities, how they're distributed.
Okay, so let's assume that the firm is rejecting the voluntary agreement. At that point, we have a probability P that the legislation will be enacted by the legislator. Okay, so this is like P. Okay, and so the probability that there will be no action instead is 1 minus P. Okay? Yes. That's the question.
Will the probability still be P in both cases? Because it will depend on...
Yes, that's interesting. Of course, you can define a P1 and P2. Yeah? So maybe if we don't offer any voluntary agreement, you might find the reason why P should be lower, maybe. Yeah? Or you might think the same for the voluntary agreement case. Yeah? Maybe, given the threats that you might impose if someone rejects the voluntary agreement, you might think that the probability will be higher in the second case. But, I mean, you can find arguments for the opposite also. Okay? Yes?
On that, so the legislator and the last step will choose to enact legislation with probability P, no matter, I mean...
In this case, no matter in which part of the tree we end up.
This is given. So
yes.
the
This is given, of course, in reality, you can try to model the probability considering different aspects and inputs. Okay, and the two P's, as we were saying, might differ. Okay.
Is that why it's 1 minus b? Because it's a given.
Sorry?
Why did you say 1 minus
Because if we have a probability P that we will have the legislation, we have a probability 1 minus P that we will not have the legislation. Okay? Just because of that. But we will focus on P, because we focus on the probability of enacting the legislation. Okay? So as you can see in this in this game 3, each step is defined by an action of one of our players. Okay? So in each step there is only one player which is acting in a way or in another one. Okay? In the two first steps we don't have uncertainty. Here we have a probability P instead. Okay? Okay. Then, now, at this point, we try to give a value to this P. Yeah? So in this case, P is 1 over 3. Yeah? Given the probability, we can try to see what is the regulator, what level of abatement the regulator needs to adapt the voluntary agreement, and what is the level of AV which is needed from the firm to adapt AV. Yeah? So we have two different interests. One is minimizing the cost, the other one is maximizing the net social benefit from the regulator. Yeah? So given the probability, both of them will will offer or accept a voluntary agreement only in some ranges of abatement. Yeah? The important is that these two ranges are intersecting in a way. Yeah? So, given the probability, for the regulator the abatement needs to be 10. For the firm, the abatement of the voluntary agreement needs to be 1. They will never find an agreement. Yeah? Usually we have a range of values. Yeah? Okay. And this is of course the thing that we want to get the voluntary agreement. Yes.
And something last is the firm able to come and show the NSP.
Sorry.
The net social benefit is the firm able to come
To
measure it.
the firm.
Yeah. So or we have mathematical asymmetric information.
Yes. I think that in reality, this is my opinion,
Yeah.
it's much easier for the firm to estimate the net social benefit than the regulator. Because the net social benefit, the benefits can be estimated in the same way as the regulator does, more or less. From the other side, for the regulator, it's very difficult to find the costs of the firm. Yeah? Of course, there is asymmetry.
No, I mean, at least for the exercise, when they come to make an agreement, do they both have the same information or?
In this case, we assume that everyone knows everything. Yeah. So, and we know that there are a range of values. We are not specific about which exact value we will get, but we know that it will be in a certain range of abatement values. Okay. So the points we are referring to are D and A. Yeah? So we have two different interests, and then in F we verify that these interests collude. Yeah? Okay. So first of all, let's read D together. Okay, we have P equal 1/3, and we don't know the value of AV. What does the regulator need to set AV to? For the firm to adopt the voluntary agreement. So, we need to impose A. Which is the convenient AV for the firm? First point. Okay. In this case, of course, we want that the cost of the mandatory scheme times the probability, yeah, needs to be bigger than the cost of the voluntary program, yeah. Okay, does it make sense? So usually we want the voluntary program to have a lower cost than the mandatory program. In this case, we take into account P. Okay? If you want to substitute C times A as with the cost function Cm of An is the same, but given that we need to calculate, it's better to plug the values already, okay, instead of the functions. Okay, we have P, we have C, yeah. What we are asking to get is AV, right? So the problem is saying we don't have AV, yeah. So we plug the values from part B, yeah. So AM was equal to 6. If you remember, CM was 7, sorry. CM was 6 and CV was 5, yeah. So we plug all these values here, and we find AV lower than 14/5, yeah. So as you can see, this is the probability, this is the cost for the mandatory scheme, this is the abatement in the mandatory scheme, and this is CV, yeah. Okay, so the abatement needs to be between 0 and the maximum abatement level of the voluntary agreement, which will be the abatement of the mandatory. Okay? Okay, given that the mandatory is always bigger, the maximum of the abatement in the voluntary scheme is the mandatory value. Yeah? So, considering the range between, considering that usually AV is between 0 and the mandatory scheme, yeah? According to our data, we get a subset of this, yeah? So, according to our values, A needs to be between 0 and 14/5, yeah? Okay? Yes?
Can you explain the H before minus BCM, AM, the payoff?
Ah, yeah, this one here. So, of course. So, if you have a probability, no? What is the payoff of rejecting the offer? Yeah? The payoff of rejecting is minus the cost. Yeah? So, this means that the payoff that you are losing, rejecting in the voluntary scheme needs to be bigger than the payoff you are losing rejecting the mandatory scheme. Okay? These and these are exactly the same. Yeah? The concept is a bit different, the reasoning. I think that this one is more straightforward. Yeah? But here is in terms of what are you missing if you reject. Okay?
Why are the payoffs minus the cost?
Because you are losing the opportunity of paying debt. And the opportunity that you are losing in the voluntary scheme needs to be bigger than the opportunity you are losing in the mandatory scheme. Does it make sense? That's good?
Sorry, can you go back to the decision tree quickly?
Yes.
I'm just trying to understand whether where it says no action, is that the firm continuing to operate just in breach of the regulations and they're not caught, or is that the legislation?
Okay, yes. You're referring to this step here, right?
Which is the no action outcome.
Sorry?
The outcome of no action.
No action, here.
No, the bottom row. I'm just asking if
Ah,
does no
okay.
action mean
Yes.
that they're being allowed to pollute, or
Yes, let's see that
catching them?
in this part of the tree, the firm is setting a level of abatement, yeah?
Yeah.
No matter what, considering the probabilities probably. And at this point, the legislator might verify if the level is below or above the mandatory agreement, or decides not to put anything. If they don't put anything in terms of legislation, the firm will not change his abatement level. Okay?
In summary, the no action means no legislation is
Taken. Yes. And so the firm will continue with the same, probably will continue with the same abatement level. Okay?
Did you, with the one you wrote on the board,
Yes.
because you assume the first equation always,
Yes.
then the second one is because AB equals 14/5. You can just put it as 14/5 because you wouldn't go over it. I don't know why you put it.
Ah, okay. So, considering all the data from before,
Yeah.
and considering that the voluntary scheme needs to be more attractive than the mandatory, we plug the values and we discover that the voluntary agreement always needs to be smaller or equal. Yeah?
Oh yeah, that's what I was going to ask. Was there?
Yeah.
Okay.
Yes, yes. Also, the abatement can be 0. Yeah? Okay. It cannot be less than 0, of course, but. Okay, so we have seen what is the interest of the firm. Now let's see what is the interest of the society. Let's look at the net social benefit. Yeah? And let's see if we have a range of values which are common. Yeah? Okay, so the question is, okay. Now, what levels of AV will the regulator be willing to offer? Okay, in this case we look at the net social benefit. Okay? So again, we have a set of values from before. We have one unknown, which is A. Yeah? So, what are we doing here? Here we are saying that the net social benefit from the voluntary agreement needs to be bigger than the net social benefit of the mandatory agreement times the probability. Yeah? Then, we put all the functions from above, yeah? So we know that net social benefit is made like this, and like this for the mandatory, yeah? At this point, we can put, we know that the benefit is equal to 20a minus a squared, and we plug it there. We have the function cost, yeah? Okay. At this point, we can simplify some values, yeah, and we can start plugging the values that we know, yeah. What we don't know is AV, yeah. So in the end, we will find a function which is a function of AV, yeah. Okay. Okay. So simplifying all of this, you get a function which is to the power of 2. Yeah? What is this function? Which kind of shape do we have here?
Quadratic form.
A quadratic form, okay. We ask the values in which this function is bigger than 0. Yeah? So, graphically, let's see if I can turn off the lights like yesterday without making us blind. Better, much. Is it manual? not very helpful, but okay. So I just want to make you understand one point. So here we have a parabolic function, yeah? So, as you know, the parabolic function is usually like this, yeah? However, as you can see, we have minus a squared plus, so minus x squared plus bx minus c, yeah? So this, in this case, our parabolic function is something more like this, yeah? Okay. And we ask to have this bigger than 0, yeah? Okay, so our f of x needs to be bigger than 0, yeah? We call all of that f of x, yeah? So we ask it to be bigger than 0. Okay, so if it is bigger than 0, yeah? This is x or a, let's say a. This is f of a, and this is f of a, yeah? Okay, so what are we looking at? We are looking at all the values in which this function of a is bigger than 0, yeah? So if you can see, in this case, the range of a will be between these two values, yeah? So most likely we will find two solutions, yeah? Given the shape of the our function, the solution will be between those two values, yeah? Okay? What if we had a function with plus a squared blah blah blah? In this case, we will have something different, maybe, no? We will have a function which is in the opposite. Yeah? Okay, we would have something like this. In these cases, where we have again two solutions, but in this case, we are looking all the values here of a and all the values here, yeah? Because these two are the areas which are positive, yeah? So we are looking at the external values. In our case, we are looking at the internal values, yeah? Why? Because our function is bigger than 0 only in that small area there. Okay, let's try to draw it again. This is our function, yeah? We ask when this function is bigger than 0, well, only between here and here, yeah? You see? So, given our two solutions, maybe we will not have two solutions, but if we have two solutions, in the usual case we do, all the internal values of a will give us a positive value of our function. Okay? Okay. Now, given that we have our function, we can find we have a to the power of 2, we have two solutions, probably, maybe, and so we need to adapt the solution process for the equalities. Yeah? Do you remember this? Yes? So minus b plus minus square root of b squared minus 4ac. Yeah? Okay? Do you remember this? I would remember this whatever, but maybe for the exam is good to have it. Just in the case we get one math exercise as we said yesterday. Yeah? Okay. So in this case, we plug all the values. We see that we have something positive here. Yeah? The square root is 12.63. And as you can see, we have two values of a. Yeah? The abatement for the range of values for the abatement in a voluntary program, if we focus on the net social benefits, needs to be between 1 and 13 more or less. Yeah? Because we are looking at these internal values. Yeah? So here we have how much is it? 19. And here we have 13.8. Okay? Okay. So we don't expect you to draw that. You can also draw like an interval, yeah? So you can have, if you want to draw something, of course. You have all the A's, yeah? Here you have AM, here you have 0, here you have 1.19, and most likely here, but also might be equal to AM, we don't know. Here we have our values, yeah? Also, yes, one second. Also, we know that for the voluntary, for the firm instead, was optimal between 0 and 14/5. How much is 14/5? 4 point something, I think, no? Okay, so for the firm, sorry?
It's less than 3, right?
Ah, yes? Okay, 3 point?
No, it's 275, right?
It's 15.
Ah, okay, okay. Ah, yes, 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 you're right. Yes, very well. Let's assume 2.7, right? So in this case, this is the amount, the range for the firm, yeah? Firm, and this is the range for regulator, yeah? So is there any interval in which they have common values? Yes. I don't know if you can see with the dark, but this section here is in common, yeah? So this means if we want a successful voluntary agreement, we need a value of abatement in the voluntary agreement in between 1.19 and 2.7 or something, yeah? Okay, and this is exactly the last question that you have here. Yeah? Okay. So here we are just saying, okay, the regulator will offer in this range. The firm will offer in this range. So we did one step more, yeah? We said, which is the successful range of values? The successful range of values is the one that makes both happy, yeah?
So between 1.19 and 14.5.
Yes, like
Yeah.
between 119 and 14/5, yes? Okay. Okay. Game over. Yes.
In the graph you drew, the y-axis are net social benefits.
Sorry?
The y-axis
Ah,
net social benefits.
let me see the function. I don't remember. Yes, 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 yes. 1 second, just to be completely clear. I think yes. Is the function which makes convenient to adopt the voluntary agreement. Yeah.
Isn't it the function of the difference between
The
net
difference
social
between
benefit and the probability of the net social benefit with the regulatory agreement? I think that's the difference because you're graphing the graphical rules of that solutions.
yeah. It might be the yeah, you can define it as the difference in benefits considering the probability. Needs to be bigger than the difference in cost considering the probability. Yeah? But not a net benefit in that case. Okay. Yes.
So to summarize, can you say then for the firm's optimal, you would just be looking at the probability times the mandatory will always be higher than the voluntary?
Yes.
Or equal No, it will be higher.
Bigger and equal.
Yeah. And then for if you're looking for the regulator, then you're just putting the net social benefit in there. That must be.
In the voluntary, bigger than the mandatory times the probability.
Yeah.
Okay. These are the two initial points. Then, if you set out these correctly, and at some point during the exercise you do a mistake, and then the range is different, well, that is a computational mistake, which is not a reasoning mistake or a mistake due to lack of knowledge in the contents. So you get points, of course, even if you take wrong results, but with the correct method, let's say.
Okay. But we wouldn't really get a question that they wouldn't intersect.
No.
Well, we could, but then it would just.
Yes.
Yeah, I agree.
Well, I think that it's in reality it's difficult to find a voluntary agreement which is great for everyone. Of course, you need to define the benefits in that case. If you are looking at the benefits to the BENVGEC2 approach, maybe it's quite tough, and then it's difficult for the firm to have the same expectations, let's say. Yes?
Is there any good example of the, in real world, for the SLP? Because I cannot understand how the E.
E, sorry. So in question E, okay. So for the question E,
The example in the real world.
yes. Let me think about that. So, like, whenever you have a regulator, even in UK, that understands for some reason, which is media-driven or evidence-driven, that they need to act in a certain sector, of course they will try to do a reasoning similar to this one. Yeah. In this case, you are trying to see probably which level of abatement you want, yeah, considering the impact on the society. Yeah.
A good impact's probably the coffee cup levy here in the UK,
Yeah.
where the government chose not to go with a mandatory tax on coffee cups and then left it to coffee, Pret and others to deal with the solution by giving discounts or giving out free cups.
Yeah.
So you've got the abatement cost of Pret, of discounting coffee, and you've got the cost of the tax on the other hand.
That's interesting. I think that in this case, they've probably tried to understand which might have been the acceptance rate from the firms. So there is also a study which is involving the how much the voluntary agreement will be successful, because as you said, also implementing a voluntary agreement has a cost, even if maybe it's much lower than a mandatory. So you do probably some research first, and then you try to offer something like that. I think that is a good example. Do you know how well is it going so far?
I think it's doing well in Pret because they give a
Big discount.
Yeah, in Pret I've read it.
But the other ones are like 10p, 20p. I don't think that's going to make a difference.
Yeah, yeah.
People who normally would always pay that price, a 10p, 20p difference.
But are Pret actually, are they doing that actually now?
50p
Yeah.
discount.
Ah, okay.
So yeah,
I
you
thought
can
they were start to implement, but
you can now get a coffee for 49p.
Yeah.
that's good.
It is. It's not such a good coffee, but it's good.
No, it's not the best coffee.
I've been telling people in the office, and now they started getting the teacups.
Yeah.
So it does work.
Yeah.
But still, it's still a very middle class thing, and compared to the vast number of cups that are being chucked away.
Yeah.
And also, I heard people saying they prefer it out of the paper cups.
Are really?
Yeah, because I was like, oh, I'm just going to take my mug from the office to Pret. And they're like, does it taste the same? I was like, it does.
Okay. So yes.
This part, why doesn't every
star into consideration.
Sorry?
There is a B star in this solution.
Ah, yes, yes, yes.
What?
So, this is not part of the questions, but here there is something more. We have this range, no? And they are asking, okay, what would be the optimal level of AP instead of the feasible range? Yeah. In this case, you will maximize the net social benefit in case of voluntary program. Yeah. Of course, this value will lie in the range that we have found before. Yeah. So in this case, you just maximize with respect to A, so you do the partial derivative, and yeah.
So AB should be no higher than 7.5.
No, let's say that probably if you look at the net social benefit, our net social benefit between 1 and 13 will do like this, and the maximum point is 7.5. Here there is another 2 missing, I think. I think there is something, there is a issue with the LaTeX, probably, because it's the second time the 2 is not there. So I will see that all the dollars are implemented in the LaTeX language. Okay, so next steps.
Sorry, just to absolute final from part F, the answer is
yes.
0 to 13, 0 to 14 over 5, is it?
Yes.
Or 1.9 to 14 over 5.
So this is, you see that the condition overlap. So here they are asking what will be the outcome. The outcome will be that they will find an agreement in the range between 0 and 14.5. Yeah? Okay. Which is 0 and 14. No, right. So here the solutions are a bit different. They say, okay, they're not doing the second step. They're just saying, okay, we can see that the firm will accept for a value of A in between here, yeah, and the regulator in between here. Yeah? Yeah. The final step, if you want to be cleaner, is saying, okay, as we can see, these two intervals cross at some point.
Which is 1.9 to 14 over 5.
In 1.9 until 14 over 5.
Okay, I just didn't follow you when you did that. That's
yeah?
Right. Got it, yeah.
Okay. Okay.
Yes. Dan, just hypothetically speaking,
yes.
If I had a total blank on doing, say, the quadratic equation,
yes,
and I kind of know where I'm trying to get to, how would you look upon that if I said it delivered that as a variable? So I said I can't work out the answer, but let's assume it's x, or let's assume it's z.
Yes.
And the answer is then 1.9 to z, or between.
Yes.
Z
so
and y.
you continue the reasoning assuming
yeah,
values.
Yeah. I'm worried about maths. That's all.
I think that of course, like with the formula and etc. is not too complicated. But if you are struggling for some reason and you continue with that, the reasoning is correct, and so you still get points.
Okay.
I don't know if alpha of the total points or something like that. If I were a student, I would expect, assuming my like estimation of grades, around half of the points.
It's better to carry on and try and explain what you're doing than to stop if you've read enough.
Of course, it's always better.
Right.
Always. Yes.
This kind of answer, like solution to 5F, two formulas and a short paragraph enough for the answer.
I would do
the analysis of or the discussion of numbers.
Yeah, I would add a discussion. Honestly, I would put maybe or a